the real reason SpaceX and NASA are going to the moon. In the coming year, the moon will be one of the most popular places in the solar system. 7 expeditions, including numerous corporations, are heading there from India, Japan, Russia, South Korea, the United Arab Emirates, and the United States. NASA's $93 billion Artemis program may steal the show this year with its inaugural launch, since it is the first step towards delivering people to the moon. However, the United States is only one of the several governments and commercial organizations planning to launch missions soon, ushering in what experts believe will be a new golden age of lunar research. Let us discuss how we may use the moon for a better good in the coming decades and millennia. We should construct spacecraft on the moon and utilize them as humanity's first interstellar spaceport to get access to our solar system. Because it provides suitable circumstances for manufacturing and launching spacecraft, the moon is our best contender for humanity's first spaceport. The resources accessible on the moon will be critical to a spaceport's success, so let us look at the true motive behind NASA and SpaceX's moon missions. The first question that arises is why the moon is the ideal location for humanity's first spaceport. Moon bases have long been a hallmark of science fiction, but a fresh drive for lunar research implies they may soon be scientific facts. According to experts, the moon's low gravity, closeness to Earth, and natural riches make it an ideal staging station for trips to Mars and other deep space destinations, as well as a new frontier for humanity to colonize. Images from the first lunar landing in 1969 revealed a cratered, seemingly empty terrain. However, NASA's Lunar Reconnaissance Orbiter, launched in 2009, has shown a surface rich in solar resources. The orbiter studied the moon's surface with various instruments, including ones that measure elevation, capture ultraviolet and visible light photographs, and detect hydrogen, along with monitoring surface and subsurface temperatures and frost. According to NASA, common minerals such as basalt, iron, quartz, and silicon have been identified on the moon. The more common materials could be converted into houses, windows, pottery, solar panels, and other items, and we may be on our way to establishing our first lunar settlement. Other rare materials have been identified as well. Platinum, palladium, and rhodium are highly conductive precious metals that might be utilized in electronics. According to NASA, scientists stated in 2011 that they had discovered titanium ore that was 10 times richer than that found on Earth. Titanium, when combined with aluminum or iron, creates an alloy that is lightweight, corrosion-resistant, highly strong, and temperature-resistant. It might be utilized to make motors, medicinal implants, and structural frameworks. There are 17 rare metals that are hard to come by on Earth, but might be discovered on the moon. These moon metals include scandium, yttrium, and others that might be employed in the vehicle engines, glass or ceramics, electrical devices, radar systems, superconductors, and other applications. With all these metals, there is no doubt that we can make rockets on the surface of Moon as well, with actual high-tech computers and technology. Helium-3 is one moon resource that is scarce on Earth, but plentiful on the lunar surface and may be cheaper to extract from the moon. Helium-3 is an appealing fuel for future nuclear fusion reactors. China, Russia, and India have all indicated interest in obtaining lunar helium-3 for use on Earth. This would need significant innovation in mining sector technology to create adequate remote procedures. Much alone, the creation of economically feasible fusion reactors, but the payback would be huge if a commercial helium-3 reactor were ever developed. The mapping of helium-3 reserves for future mining and exploitation might be one of the aims of future moon expeditions. The revenues might be enormous, with a kilogram of helium-3 predicted to price $3 million. A strong lunar economy will make off-world activities lucrative, allowing us to conduct more expeditions and learn more about the moon and other bodies. There are incredibly rich resources on the moon that may sustain the lunar economy and be very beneficial in making the space exploration dream a reality. Minerals are not the only feature that makes the moon the best candidate for a space station. With its low gravity, absence of atmosphere, and ease of launching deep space missions, the moon is a tremendous resource for anything from astronomy to low-gravity material manufacturing to a logistic node for a voyage to Mars. The rocket equation is what allows scientists and engineers to calculate and evaluate the energy necessary to reach various locations in space. Its ramifications are far-reaching yet not clear, so I'll try to explain them without using any maths. According to the rocket equation, the amount of energy required by a rocket to go from the Earth's surface to a 250-kilometer high orbit known as the low Earth orbit is nearly 3 times that required to travel from low Earth orbit to the moon. Similarly, reaching low Earth orbit consumes twice as much as energy reaching Mars from the same orbit. Even when we include the energy required to land on the moon, rather than just reach it from the low Earth orbit. Getting to Earth orbit is around 50% more expensive. In other words, achieving Earth orbit is the first and most critical obstacle to space exploration. The rocket equation not only determines how much energy is required to reach certain locations in space, but it also determines whether you can reach space at all. Furthermore, having a permanent human presence on Mars makes sense for humanity's long-term survival and growth, since it provides us with a reasonably benign climate. This would need transporting tens of thousands of tons of material from Earth to the Martian surface via hundreds of massive rocket launches. That is exactly what SpaceX's Starship intends to do. The moon, our heavenly companion, can help here. Because our moon has far lower gravity than Earth, rockets can take off with ease. This was most noticeable during the Apollo missions, when even a spacecraft carrying 2 people could glide into lunar orbit. Furthermore, the moon is located on the outside of Earth's gravitational well, making it simple to escape our planet's pull entirely if launched from the moon. In fact, it's nearly 5 times easier. We can someday launch rockets from the moon itself if we first build a large permanent community on the moon. NASA and Indian Space Research Organization satellites have identified a lot of water ice in the moon's poles. Future human homes constructed from mining the metal-rich lunar soil may draw on this water ice for consumption. This water may also be separated into hydrogen and oxygen, which can then be used as rocket fuel. Rockets launched from an industrially capable moon base can travel faster to Mars than from Earth. Building an industrial moon base would be costly, but if the objective is to extend sustainably beyond the solar system, we're talking about hundreds to thousands of years, not decades. In the grand scheme of things, the moon can serve as a rocket platform for establishing and expanding a sustained Mars presence at a considerably lower cost than doing it from Earth. Because of the moon's accessibility, lower gravity barrier, and resource potential, proponents advocate for a sustainable return to the moon first rather than Mars. If the argument for Mars through the moon isn't compelling enough, the moon's benefits extend to establishing a presence in the outer solar system as well. The rocket equation informs us that while objects in the solar system's outer reaches may be closer to Mars than the moon, the deeper gravity well of the more massive red planets requires more energy to escape than to reach those destinations from there. Getting to the asteroid belt from the moon's surface requires at least 40% less energy than getting there from Mars's surface, despite the fact that Mars is nearly 75 million kilometers closer to the belt. This is the difference that gravity produces, and which the rocket equation allows us to perceive. The moon can hasten the expansion of human colonies to these resource-rich asteroids. Some of these objectives, such as Ceres and Vesta, potentially fulfill the same function as the moon for Mars and the asteroid belt, allowing human settlements to spread beyond Jupiter and Saturn's moons and even beyond. Finally, the one most significant point from the rocket equation: the capacity to harvest and exploit raw minerals from resourceful low-gravity space objects would liberate humanity from the tyranny of hauling things out of Earth's gravitational pull. We can't expect to go among the stars if we don't first establish across the solar system in an Earth-independent manner and access a far broader resource pool. In space, manufacturing and industrialization is not a nice-to-have, but a must-have for further development beyond the solar system. Only then will mankind be in a position to go to the nearest star, perhaps before the sun goes dark. The ultimate goal is undoubtedly Mars, and any crewed voyage to Mars will have to be preceded by several reconnaissance and preparation operations. In any sustainable resource, development of Mars will need hundreds of expeditions. It may be significantly more practical and cost-effective to build as much as we need on the moon and transport it to Mars from there, rather than all the way from Earth. The moon contains a lot of frozen water that we could collect and utilize to manufacture rocket fuel to refuel our spacecraft, making return flights cheaper and future expeditions simpler. The rockets themselves will not need to be as large, making them less expensive, and we will be able to send supply ships and one-time exploratory missions to sites around the solar system more readily. So let's get started. Let the moon become the 8th continent. So we can say that our next mission to the moon will be one of the most significant steps forward in the history of space exploration, because of all it will bring to the table. What do you think of this lunar settlement? Some people, like Amazon CEO Jeff Bezos, believes that using resources from the moon and possibly establishing a community there is unethical. So there are certainly advantages and disadvantages to this objective. But let the higher-ups make the decisions for the time being because they are the ones that work tirelessly to improve our lives. What are your thoughts on this voyage? Will it be a success?